The NASA Lunabotics RMC competition is an annual engineering exercise where students from across the country compete to design a robot to perform operations on the surface of the moon. This robot is intended to navigate either through telecommunication or complete autonomy on the lunar surface, collect moon regolith, and deliver the rocky payload to a stationary receptacle. The moon regolith contains usable resources such as oxygen and water that can enable the production of fuel, water, and oxygen locally on the moon. The ability to produce these resources on the moon decreases the amount of material needed to be sent by rocket from Earth to Earth's orbit, which is an expensive process. During a time without the pandemic, teams representing universities from across the United States travel to Florida to compete against other teams in a time-restricted mining simulation. The teams are given 5 minutes to set their robot up, 5 minutes to have their robot collect and deliver as much simulated regolith as possible, and 5 minutes to remove the robot from the mining area. Each team is judged based on many factors of operation, where points are awarded or deducted based on NASA-defined performance. The Colorado School of Mines team Selene prioritized these judgment factors as the primary basis for design. The team prioritized the excavation system, movement, and data transmission aspects of the robot. Secondary concerns include energy consumption and weight management. The areas of least concern include dust mitigation and automation due to the time constraints. Team Selene broke the challenge up into 5 subsystems that are divided amongst team members: drivetrain and chassis, excavation, collection and dumping, controls and navigation, and power. During the stages of development, Team Selene innovated and produced novel solutions for the complex problems presented by NASA. Some of these solutions include a center-mounted excavation wheel, a lightweight aluminum chassis, and a dynamic and scalable TCP-based wireless communication system. Since Team Selene is unable to compete due to the coronavirus pandemic, the subsystems built this year were designed with the purpose of being taken to competition by next year's team. Team Selene has produced extensive documentation and resources to see Colorado School of Mines' Lunabotics robot reach its full potential to compete in Florida next year.